Hello. Today I'm going to show you how to make a battery interrupter. But before I do that, I'll take a moment to explain what that is and why it's useful. This is a battery interrupter. And what it does is it gives us a simple, effective way to make an item like this battery powered dice roller to be accessible by a switch. Now, I have already adapted this with the surface mounted jack for a switch, but let's pretend that's not been done that way. Another way that this could be done is that you interrupt the flow of electricity at the battery compartment with a battery interrupter. Now, my demonstration here is going to fall apart a little bit here because this is one that's made for a C or D sized battery, and these obviously are AA. But if you imagine it smaller, the metal coated disc here would slide in between the end of the housing and where the battery would sit, thus interrupting the flow of electricity. And at the other end is a female 1/8 inch jack, or 3.5 millimeter. And that's where your switch would get plugged in. So then, anytime the user switch is activated, that completes the circuit of electricity and will activate your item. That has to be able to be normally on or off, like a light switch. Okay. Now we'll see how we make one of these battery interrupters. Not too complicated, really. So I have a little kit here with all the parts we need to do this. And so I will lay these out for us. Here I have some simple 2-conductor 22 gauge wire. Notice this is only 6 inches long. That's plenty long because the user's switch is going to get plugged into it. This does not need to be that long, just long enough to hang out of the toy or other item that you're going to plug it into. We have a female jack. Again, that's 1/8 inch or 3.5 millimeter. And that's going to be soldered onto one end of our wires. We have, this is actually a piece from, you can use either a credit card or gift card that's been used. And so we've trimmed it down to the appropriate size. That size obviously will change depending on what type of batteries that you're going to be interrupting. So this is good for, this is perfect size for a AA battery. So we'll use that. As in the battery interrupter that's already made here, that's coated with metal on either side, we're going to use this copper tape to provide our metal covering on either side, on both sides of our plate there. We have several pieces of shrink tubing that we'll be using as we solder everything together. And this is just a simple Velcro strap to keep everything tidy at the end. And in fact, we probably won't need that. Okay. First, let's go ahead and prep our wire. Actually, my solder station, I've already turned it on. So the first thing you do, once your iron is heated up, before you start using it, right, we're going to clean off the tip in our little copper bucket. And then I'm going to apply some solder, fresh solder, to coat that tip. Coat it well, and I'm actually going to dab off or wipe off the extra. But now that tip is ready to use. You may not be able to hear, but I have a fan running to ventilate my area adequately. Okay, presto, my wire is now prepared, which you've seen in other video clips. So the insulation has been stripped about 1 centimeter from each end on each wire, and then I have pre-tinned so that we get a better connection. So those are all ready to go. Pro tip, we know this is 22 gauge wire, and there is a notch marked for 22 on our wire strippers, but you will find that if you use the notch marked 20, which is slightly bigger, you'll actually have a much easier time of preparing your wires, stripping away the insulation. If you use the 22 spot, quite often you'll cut too deep and lose some of your copper wire in the middle. All right, so next, let's go ahead and put our female jack on. To do this, we're going to want to use at least one piece of shrink tubing to provide a good clean connection. Do it on that one. Okay. Now there are a few different ways to do this, and really whatever you're comfortable with. I prefer, I'm going to put a little bend in the wire to thread it through beforehand, like so. Okay, so if you can see right here, the wire's threaded through the hole there. And now I can apply my heat on one side, a little extra solder, hold that in place. And that's on there successfully. Okay. Now I'm going to go ahead and move my shrink tube in place right now, because if I wait and try to do it after I've soldered the other piece, I might heat it up accidentally before it's in place. So now the second wire is going through the middle. Feed that through. You can rotate this to get a good angle. There's where we're soldering. Apply some heat. Quick little dab of extra solder on there. And it's done. Okay. Now a couple of things here. You can see there's some extra wire on the other end of the solder joint that's really going to get in the way. So I'm going to trim that back. There we go. If you can see these little tabs here that can be folded down, I'm going to do that now. Get them out of the way, and it provides a little more security on that one wire. Okay. Now we'll heat up that piece of shrink tubing. Honestly, this would probably be fine without the shrink tubing, but it's better safe than sorry. You never want to have a short. That's going to be the most likely problem you can have, and very easy to avoid. So you don't need to like roast your shrink tubing. Get the heat near it. You can see already it's kind of shrinking up there. There. Done. All right, now you can see there's no way we get a crossover and a short on that. Okay. Next, we're gonna put, just to make it a little extra strong, I've got another piece of shrink tubing here, larger diameter, that will easily encompass both of these wires. Now, my other end is completely open, so I didn't have to worry about feeding on things like this extra shrink tubing or the housing that has to go on last. But if I had something on this other end already, gotta remember to feed these things over the wires beforehand. Otherwise, later on you'll get stuck and have to backtrack on your work, and that is always a bummer. Okay. Now the other piece of shrink tubing is in place. Bring the heat. Rotate. If you apply too much heat, especially with the cheaper shrink tubing, it will split on you. Okay, that looks pretty good. And we'll put the housing over once we get our ends to cooperate. Come on. See, this other end is narrower, so you gotta kind of line everything up well. There we go. Twist it in place. Okay. One other final thing that we can do here is to add a small zip tie that will really give us a little extra strength. You know, anytime with a cable, I guess it's just human nature, people pull on this end piece all the time. So if you take a zip tie, wrap it around once, right here on the base of this bottom area, cinch it up nice and snug. Now, I'm going to cut off the extra. If the user does pull on this, it's not going to pull right on the soldered joint. It's all firmly connected together now. Okay, we're getting there. Now to do the other end of our battery interrupter. Okay, now we're going to take care of the business end of our battery interrupter here. So we need to trim up 2 pieces of this copper tape, or enough copper tape I should say, to cover each side, yes, both sides of our piece of plastic. You want it to come very close to the edges, but not quite to the edge. That way you avoid having a short again with the 2 sides coming in contact with each other. So, kind of eyeballing this. Cut right about there. And then, just like on my plastic where I've cut the corners back, just to help make sure things fit well in the battery compartments, I'm going to do the same thing on my copper tape. Okay, let's see how that worked. I went a little vigorous on the corners, but that's okay. So if you can see there, that's gonna work okay. I've got a fair amount of room on the sides, but it should work okay, I think. All right, so now I've trimmed that up. I have to carefully peel back the paper from the back side of the copper tape, like so. And then place it on our plastic. Here is where your fine motor skills will be challenged. There we go. And again, I could have done it a little better, but that will work. Okay, you basically got to make sure, you know, that where the battery's going to come in contact with that, and that shouldn't be a problem. We'll see if I can do the second side a little bit better. Okay. Cut the corners back, not quite so aggressively. Okay, let's see here. Yeah, that looks good. Okay. Okay. Again, try to match this up real well. A little crooked, but it will work. Okay. So now, and you know, if you're doing a battery interrupter for a larger battery, you can absolutely use more than one single piece of the copper tape. Absolutely. So now we're going to solder these two guys together, and there's a couple things to do in preparation for that. We now have something on the other end of our wire. That means everything we need to thread on to our wire beforehand, we have to do that right now. So, get our shrink tubing, my larger piece that I want to use, a couple of smaller pieces for the individual wires, and I do want one for each this time. Now, notice I'm giving myself a good couple of centimeters of clearance, because if you have the shrink tubing too close up to the front where you're going to be soldering, the heat does transfer, and these will start to shrink up, and then you'll have a hard time moving them into place later when you need to. So make sure you do that. Okay, so everything there is in place. Now, the other thing I'm going to do is, beforehand, I'm going to put a little dollop of solder right on my copper here to use in a little bit. Come on. Oh, I forgot. My iron was turned down. You're not going to do much without the heat you need. Luckily for me, I have a Boss of a Weller soldering station that heats up in just seconds. Very nice. I am running at about 550 degrees I kind of like my stuff pretty hot. But you'll be able to solder just fine at a lower temperature if you happen to have a less expensive, basic soldering iron. Okay, now let's try this again, shall we? So, put a little dollop right there, you see that? Solder right on. Same on the other side. Now, notice, even with just that brief moment, this credit card plastic started to flex a little bit. So be careful about leaving heat on there a long time, because it is plastic and it's going to do that. Okay. And if you do see it, try to do what you can to get it back to flat as much as you can. Okay. And if you need to, give it some time between working on it on one side and then the other. Okay. So, now notice I'm bringing my wire, exposed wire, right all the way up to, and maybe even if I need to, slightly past the edge. So there's, again, no chance of crossing over, right, from one side of this to the other. Now, so the reason I wanted to put that solder on beforehand, I now should be able to solder these together with the briefest amount of heat added. And because we're using this plastic, that's what we want to go for. The other thing too with these, you want to really try and work it to be as flat as possible. Alright? You don't want to have a big tall clump on either side, because then you're going to have a harder time getting everything to connect the way it's supposed to and work inside the battery case of your toy or whatever it is that you're adapting for. So, yeah, as flat as possible is what you want. That's what you desire. Now, what I kind of screwed up a little bit on earlier was I did not put my solder clump quite close enough to the edge here. So let's see how this works. Again, you gotta have a good connection, but you also want it nice and flat. Okay, there. That worked out pretty good, actually. So, pretty flat. My credit card section is still fairly flat. Now, I'm moving my shrink tubing right up into place on both sides. Okay, let's apply some heat for the shrink tubing. Okay. All right. Now, again, as we did with the other side, if you add another zip tie, you're going to get a little bit extra strength. It's going to be helpful in the long run. I can pull it out here. But yeah, so this is the catch here. See, in the battery compartment, you have very little room. I could probably get away with this if it was like a C or D sized battery, but with the double or triple A, I think I'm going to not use the zip tie in favor of keeping things smaller. Okay, so now we're basically done. If you wanted to, you could sandwich the soldering joint with another piece of copper tape over the top on each side, but that's just making the whole thing thicker, and unless you're having a problem, I would probably stop right there. Now last thing you're gonna do is you're gonna test it out. Okay. So, I'm going to remove the battery, and what's best is to put, well, I find it best, is to put our interrupter at the end with the spring, because that's the end that the flat side of the battery, the negative terminal, goes to. And it's just going to be easier to get everything to line up the way you need to. Like I said earlier, this is often really tight. Okay, but we got it in there. Often what you'll need to do on the cover is you'll need to cut out a little notch for the cable that's coming out. But that's pretty much set right there. Now we just need a switch. Here's our switch to plug in the other end of our battery interrupter. It's a good sign that it didn't do anything right away, because if it started going before we depress the switch, that's a good sign you've probably got a short. Now, to test it as a battery interrupter, I have to have the normal button depressed. So now the only break in the loop for electricity is my button. So let's see if it works. There's our functioning battery interrupter. So again, as a tool, this is very nice. It can be moved from one item to the next, and it's fairly simple to make, but again, it has to be in a situation where the item is like normally on or normally off. So like in our example here, it's where we would have this wired so this button was cut out of the loop. Something like a fan, when you have it either always on or always off, something like that. All right, thank you.